So today we are talking about systems of equations using technology. You guys are basically going to learn how to use your graphing calculator to solve a system. Now there is a program within your calculator that allows you to solve a system of equation. However, you guys have been doing system of equations ever since Algebra 1. Who remembers how to solve a system of equations algebraically? Substitution was one of them. Elimination, and then the one that's not really taught anymore, but it's still a way to solve a system is
logs.
Not logs. Graphing. Yes. Okay. So those are 3 different ways that you guys learn how to solve a system. Okay. However, for this particular IB class, you just really need to more so know how to use your calculator to solve a system when you're presented with a particular problem. But like I said, if you don't remember the process and everything like that, you can always fall back to solving using elimination, substitution, or graphing. The only issue with that becomes when you get beyond a 2-variable, 2-equation system of equations. You may have 3. You may have 4. You may have 5. That's when technology comes into play, and it's a lot more helpful than trying to do it all out by hand because it can be very time consuming. Okay? So you're going to learn how to do that using your calculator, okay? But to start, let's make sure that we know all the pieces that consist of a system of equations. All these words, maybe parameters might be a new word for you, but the other 2 words should be familiar in your math vernacular. So coefficients. The number before a variable. I like that definition. The number before a variable. Are you writing that down? The number before. I like that definition. Okay? Okay? If you think about any type of equation that we deal with, if it's 2x squared, the coefficient would be the... Exactly, okay? What about parameters? Think about it. We're talking about an equation. The coefficients, the number in front, the parameter could potentially be the variable. Yes, okay? Parameters are basically the variables that you're dealing with. It's also basically known as your unknown. Okay, so your variable or your unknown. And then last but not least, you have your constants. Constant. Familiar word.
Stays the same always.
True. So that is what a constant is. It stays the same always. When we think about an equation, when we're talking about the constant in the equation, what is that?
It keeps the same value.
Okay, so what would that be in an equation? Not the variable, because that's a parameter. It's what? The number without the variable, yes. Is the number without a variable. So you're right, it's that number that stays the same and never changes, and the number that does that is the constant. Because any other number that has a variable attached to it is going to change. So 2x, it could be 2, 4, 6, 8, depending on what that variable is. So it's ever changing. But the constant is the number that's without a variable that will always stay consistent.
It's just a coefficient that doesn't have a variable.
Correct. Oh, I like that word. Look at you using your vocabulary. Coefficient. Okay? So we know the pieces that make up our equations for our system of equations. And so if we have some data, okay, a lot of times when you're solving these systems, it will come from some type of word problem or some type of data that's given to you. If you have some data that the model needs to basically fit, okay, you're trying to basically create the equation to model a particular data, we can substitute in different points of that data into a function to construct a, what are we talking about today? System. Thank you. A system of equation with technology for the unknown parameters, aka variables. Very good. And by solving a system of equations simultaneously, because it's not like we're going to solve one of the equations and solve the other equation and solve the other equation individually. We're going to solve them at the same time. We obtain the variables which will complete the particular model. Okay? So let's go ahead and let's look at a few examples of how we can use our technology to solve a system. So the table alongside shows the quantity V of air affected by smoke T seconds after the fire is started. Okay? So V, in this case, going to represent liters. T represents seconds. And this particular data is modeling the first 3 seconds of volume. V and T are connected by a cubic model. So this time you're given exactly what type of model is going to represent this data. And it's V equals AT to the third plus BT squared plus CT. We're looking to find the coefficients of A, B, and C, which will actually complete our model. So, how do you use your calculator to do this? Okay, hopefully, I'm praying that everybody's calculator has the ability to do this. If not, I'm going to have to show you a different way that's a little bit longer, but it still gives you the same result. Okay, so your graphing display calculator instructions are as follows. Let me get out of this. That's exactly where we need to go. Okay. All right, when you turn your calculator on, the first thing you want to do is you want to go to apps. Okay, press that apps button. That's the first thing you want to do. Okay, in apps, you want to go to Polysymult 2. Okay, that basically stands for polynomial simultaneous equations. Okay, if you do not have that feature, then just hold off and I'll show you the other way that you can do this. Okay, so you're going to go ahead and click on that option. So in my case, it's going to be option 4. I don't know options on you. And then it's basically going to pull up this application that's installed on the calculator for polynomial root finder and simultaneous equation solver. These are simultaneous equations that we are solving. So we click any key to continue. It really doesn't matter because it takes you into the main menu. After that, you're going to go to option 2, simultaneous equation solver. Okay? So you're going to go to option 2, simultaneous equation solver. And basically, once you go there, which is option 2, you need to basically let the calculator know, okay, what exactly am I dealing with here? Okay? How many equations am I going to have? How many unknowns? Do I want my answers as decimals or fractions? That's what the dec and frac stand for. Of course, you want to leave it to normal. If you change it to any of the other ones, you're going to basically change the format in which your answers are given. And you want to float. Float basically means that it's going to give you as many decimals as the calculator can hold if it is a decimal answer. And, of course, if you set it to decimal. And radian degree, because this is not a trig equation, it's a cubic model, we don't have to worry about that bottom part. Okay? So, let's figure out exactly how many equations we have and how many unknowns we have. Okay? So, this is the model that we are trying to create. And here we know that after 1 second, my volume is 2. After 2 seconds, my volume is 4. After 3 seconds, my volume is 12. I can create equations for each one of those data points. And I do that by basically taking the value of B and taking the value of T for each set and plugging it in to the model that's given to me. Okay? So for 1 second, my volume is 2. So then that's going to be A times 1 cubed plus B times 1 squared plus C times 1, which is basically the same thing as saying 2 equals, what's 1 cubed? So this becomes just an A, because it's 1 times A, which is A. What's 1 squared?
1.
So that becomes plus B, and what's C times 1? C. So that is one of your equations. That models that first data point that's given to you. And I repeat that same process for the other 2 pieces of data that I'm given. If I was given 4 or 5 or 6 pieces of data, you want to create that many equations based off the number of data points that you are given. Does that make sense? Okay? So my next one would basically be 4 equals A times 2 cubed plus B times 2 squared plus C times 2. Now, would I write out this line right here, what I'm writing on the left side? No, I'll probably just give the right side product. So this would be 4 equals, what's 2 cubed? 2 cubed is 8. Question? Okay, so how did we get the setup for the equation basically? We're using this model right here. The b equals at to the third plus bt squared plus ct. A, B, and C basically represent our coefficients. And we're trying to figure out what are those values. So that way when we attach it to our variables in the equation, it gives us the best model for this data that we're given. T, which is 1, means that for every t value, I'm going to plug in a 1 into that general equation. And then I'm going to plug this in for b in that equation to create one of the equations for my system. So that's how I'm able to get the 1 cubed, 1 squared, and then the 1 because I'm basically plugging it in for the t in this equation. I know it doesn't really look like a t because the font that's used, but that is your variable. That is your parameter. Make sense? Mm-hmm. So 2 cubed is 8, so this becomes an 8a. What's 2 squared?
4.
Plus 4b. Then plus 2 times c is just 2c. Okay? Simple math right now. Cubing, squaring, yes. Okay? The last one, when I set it up, I'm going to go ahead and set it up. I'm going to have 12 equals, what's 3 cubed?
27.
27. So this becomes a 27a. What's 3 squared? Plus 9b plus 3c. And so these are my equations based off of the data that I'm given. And this is my system of equations. How many parameters do we have here? We have 3 parameters, variables, unknowns. How many equations do I have here? 3. So that part in your simultaneous equation solver, when it asks you equations and unknowns, you need to basically change that to fit whatever you're given. So all I do is just press enter in the equations, like I move over to the number it is, click enter, I move over, click enter, and then all I need to do at this point to figure out the values A, B, and C is go to next. Okay? Next is located right above the graph button, and like you literally have to press the graph button for it to go to next. Okay. Any questions up to this point? All right. Now, what's about to happen here is what for people who don't have simultaneous equation solver are going to have to do. Okay, so if you don't have this, what we're about to do at this point, you're going to be doing as well. Okay. Your number of equations, because I know you're probably thinking, okay, what about this blank over here, should match your number of unknowns, okay? And if it doesn't match, then that probably means that, not that you made a mistake, but as long as your equations either are equal or greater than your number of unknowns, then you're fine, okay? It should never be the other way around. So, this right here is called a system. A matrix. And basically what these little spots represent are the coefficients of the equations that you set up. You see this dark line right here? That's like the equal sign. Okay? So all you need to do at this point is plug in the coefficients for each of your equations and your solutions. So what's on the other side of the equal sign on the right side of that line, and then you'll be able to solve. So for my first equation, all those coefficients for A, B, and C are all 1, so I'm going to click 1, enter, 1, enter, 1, enter, and all of that was equal to 2, and I click enter. So I'm plugging in the coefficients of the equations that I created. The next line, 8, 4, 2, and all that equals 4. It will matter. It does have an effect on the where you put the coefficients, it will matter. So you want to make sure that they're in order. All your A's are first, all your B's are second, all your C's are last. Then you have 27, 9, and 3. And the last one is 12. Click enter. Once you have all that in, you double check, make sure I didn't make any mistakes. Good. And then you just go to solve, which again is the graph button. and it provides you with your answers. Now, of course, they're not in terms of A, B, and C. I mean, you don't have any control over that, but as long as you put it in order, x sub 1 is equal to x sub 2 and x sub 3. So then those are your solutions.
So, wait, for the second equation, the coefficients are 8, 4, and 2.
Yes. So then you'll say that A equals 1, B equals, and C equals 4. There you go. What work do you write down? What do you put on your paper is not apps, polysomulti. You don't write that down. Do not write down calculator notation. On your test, when you see no calculator notation, realize I talked junk about you to my parents when I was grading this over Thanksgiving. Okay? I tell them how many times I told these students not to write any type of calculator notation. So if you see no calculator notation with the exclamation points, just know that I was yelling about you to my parents. Okay?
Wait, I have a question.
You write the equations. That's the work you show. And your answer. Your question.
Do we press, like, how do we get the answer? We press graph.
You press graph, which is the solve feature. You see the little options above on the screen. That's it.
Miss Anderson, since like my calculator doesn't have like the
Yeah, I'm about to show you how to do it. Okay?
Okay.
So for those who do not have that feature, Mohammed's one. Anybody else? Okay, we got a couple. All right. So, anytime you want to get out of this program, because it is a program in your calculator, you press second mode. Okay? Second mode, because it's quit. Gets you out of the program. Okay? Because if you're trying to go back to your home screen. All right. So that's what I needed to do. Now, for those who do not have this feature, what you're going to have to do is you're going to have to press, and you probably want to write this down. You need to press second, and then you need to press the x to the -1 button, which is right below your math button. And it's still highlighted in red. Above that button says matrix. Basically, what you're going to need to do is you're actually going to need to create the matrix that's going to give you what it is that we're trying to do. So second x to the -1, and you're going to need to go over to edit. Okay? Now, this feature is also really good for anybody who takes the ACT and it happens to be a matrix problem in there, and you want to try to, multiply or add or do anything to them. This is exactly what you would need to do. So this is actually very good for everyone. You want to go over to edit. Edit basically allows you to create the matrices of what pretty much was on the application. The only downside is that you're going to have to do them individually. Okay? So all of your unknowns, all your parameters, one side of your equal sign will need to be in one matrix, and then the other side will need to be in a second matrix. So to make sure that you don't confuse yourself, make matrix A your parameter matrix. That was a 3x3 matrix. How do you know it's a 3x3? You had 3 equations and 3 unknowns. And it's always based off of that. You go equations, then unknowns. Equations, then unknowns. And then it looks just like the matrix that you saw in the application. You type in your coefficients. 1, 1, 1, 8, 4, 2, 27, 9, and 3. Now, I need to do another matrix for my 2, 4, and 12. How did I get to matrix? What buttons did I press? Second. X to the -1. Very good. Now I need to put in this matrix, so I need to go over to what? I need to go over to edit. And I don't want to edit matrix A because that's where my unknown matrix was. I need to edit matrix B. Okay? So I'll go to matrix B. Question?
Mine says 3x3 on C, like 3C on the line.
So there's already something in that matrix? Or is that where you put it?
No, it says like 3C and then 3x3.
That's fine. That just means that whoever used the calculator before you put a matrix in there. The thing is, like, you can have up to, I think it's all the way up to like G or something like that. It's fine because we're basically going to pull from the matrices that we need. Now, How many equations was this? It's a 3. And since I'm only doing the left side of the equal sign, it's a 3 by 1. Okay? And then we just type it in 2, 4, and 12. Have I lost anybody? Now, for those who have the poly-simultaneous equation solver, that's fine. But like I said, ACT, when they have matrices problems and things like that, and you want to maybe get a few extra points, this is how you would use your calculator to do it. Okay. Now, go to second mode. Go back to your home screen. And now we're actually going to find the solutions. Okay. You need to go back to matrix. So where is that located?
Second x to the negative 1.
Second x to the negative 1. Now this time I actually need to retrieve these matrices. So I need to stay on names. I don't want to go to edit. I've already edited. So you're going to go to enter. And basically what it does is it basically pulls that matrix A to your home screen. And the same button that you press to get to your matrix, you're just going to press it without the second button. So your calculator should show matrix A to the negative 1. And then go second matrix again. And go to matrix B. So that's what your home screen should look like. And when you click enter, you get the same solutions that we did. Okay? So both options have a series of steps, and to be honest, the more you do it, like the quicker you'll be with retrieving and typing in different things and so on and so forth. We're going to be using matrix again when we talk about chi-square when we get to statistics next semester. So everyone's going to need to know that feature.
That didn't happen with mine.
Okay.
It just said matrix D.
So the main thing with this is you want to make sure that your number of equations either match or are greater than your number of unknowns for you to be able to go about basically solving a simultaneous equation. Let's look at this one. It says the points 1, 7, 2, 10, and 3, 11 lie on a model in the form of, that is a typo, y equals ax squared plus bx plus c. We need to construct our 3 equations in terms of a, b, and c. Remember what it says in terms of, that means that a, b, and c should be a part of your equation. Of course, we're going to use technology to find the value of a, b, and c, and hence we are going to actually write what the model is. Okay? So in this particular case, when I write my equations, what am I plugging the points into? So this is the model that I'm going to plug my points into. So if I were to use 1, 7, I will plug 1 in for x and 7 in for
Y.
Very good. Okay, so create my 3 equations. Sorry, never mind, I said 3 equations. So you're going to do each time for each set of the points. Use your technology to find a, b, and c. And then once you find it, you actually have to write the actual equation. So y equals the actual equation, okay? So go ahead and do that now. Write your equations. All right, Dylan, give me one of the equations. Very good. Roderick, give me another equation.
10 equals a, wait, what? Like, oh, just from the beginning? Okay. 10 equals a times 2 squared plus b times 2 plus c.
Okay, so then once you did that, you got what equation? Like simplify it. So what's 2 squared?
Oh, so that would be 10 4a plus 2b plus c.
Good stuff. And then Isabel, the last one.
11 equals 9a plus 3b plus c.
Very good. Okay.
Wait, what
Now-
about the 2?
What 2?
The 2 that's behind the ax.
And remember I said that was a typo. It should have been a square. That should have been a square. Yeah. I mean, think about it. If it was just a 2, then this would just be a linear function. This is definitely not a linear equation, though. Quadratic one. All right? So now I go into my calculator and I do the fancy thing, or I gotta do matrix depending on what kind of calculator you have. If I'm using the application, I need to make sure I go into apps, option.
4.
Well, for me it's 4, and then once I get in here, I press any button and I go to option 2. Good stuff. How many equations?
2,
How many unknowns?
3,
I want everything to stay the same. Here, what am I typing in?
coefficient. 1, 1, 1 equals 7.
Equals 7. So change that to a 7.
4, 2, 1 equals 10.
4, 2, 1 equals 10, and
9, 3, 1 equals 11.
and then I go to
Graph.
which is solve. And did I get this? Did you get this? So -1, 6, and 2. Those are numbers, right? If you did the matrix, did you get these values as well?
Yeah.
Okay, good stuff. So the final thing is I actually need to write the model. So this becomes y equals -x squared plus 6x plus 2. You actually have to write the particular equation, which basically means is that if I were to graph this and I were to go look at the table, 1, 7, 2, 10, and 3, 11 would actually be points on this quadratic. Okay, that's how you use a model for a set of data points or something like that. Okay.
So our answer on the test is y equals -x squared plus 6x plus 2.
That would be the actual model. Yes.
How'd you get that?
Uh, not always.
Like a y equals thing.
So then you'll have to kind of know your general setup.
Plug it.
Oh, so the question was, can you just write your answers like this? And I said yes. Now the one thing again, your work is the equations themselves. Being able to set the equation. Now how you go about solving it, that's completely different. Because this is a 3-variable system, which means you have to go through like a whole process of elimination and substitution if you want to do it algebraically to show your work. And they're not expecting you to know how to do that. Especially if it's more variables and more equations. Okay? Let's look at this last example. Okay? This graph shows the relationship between the height and radius of cylinders which have a constant surface area, so a surface area that's never changing, but the height and the radius are. The model connecting H and R has the form of H equals A divided by R plus BR, where A and B are your constants. We're going to use the given data points to determine a model connecting R and H. We're going to use the, A and B are on the other part. We're going to use the model to find the value of H when R is 9. And is our answer reasonable? We're going to figure out for what values of R can this model be correctly applied. And then, of course, after that, we're going to use the data points to determine a model that connects them. Use the formula for the surface area to explain why the model form is reasonable. And also to find the constant surface area for these particular cylinders. So, application problem using simultaneous equations, asking a few other things besides just figuring out what's the model. Okay? Let's see if you can apply it. Use your model to find the value of H when R equals 9. Or is this misnumbered?
Yeah, I was seeing a problem
Yeah,
there too.
sorry, yeah, it is misnumbered. Hold on. So we're gonna go, yep, this is misnumbered. Sorry, so this probably should have been A, B, C, yeah, D, and E. Okay, sorry, this is misnumbered, a mistake. So let's start here. We're gonna use the given data points to determine a model that connects H and R. Well, if I look at that equation, and I don't know how good it is on your paper, but how am I going to create this model? I'm probably going to need some points, right? Which points am I going to use?
2 and 16.
Uh-huh.
4 and 5.
4 and 5. Okay, so this time it's only 2 points, not 3. And which model am I going to use?
H equals and then A divided by R plus BR.
Excuse me. Yes. Now, which one of those coordinates represents? So if I look at 216, which one of them represents R? Which one of them represents H?
2 equals H.
Which one is it?
2 equals.
2.
No,
That's
2
right.
equals R.
2 equals R, and 16 equals H. You can also look here. The horizontal axis is R, vertical axis is h. Technically, that's x and y. So, if I were to create my equations so that I can get my model, how would I set it up?
Oh shoot. 16 equals, and then A divided by 2 plus B 2.
Or 2b?
2B, yeah.
That's one of my equations. Do I have another equation?
Yeah. 5 equals A divided by 4 plus 4B.
Good. Do I have any more? I could,
But I don't want
but you don't want to. I could if I knew exactly what the model was and I could pull out other points that are on it, but I only have these two to basically create my model with. So this time, it's not going to be, how many equations is it?
2.
And how many unknowns?
Those.
2.
2. So that means when you go into your application and you go to your simultaneous equation solver, you're going to need to change those to a 2 and 2. And that also means for my matrix people, when you go to your matrix, it's not a 3 by 3, it is a
2 by 2.
2 by 2. Okay? So we're actually trying to figure out what the model is. So I need to know what A is and what B is. So can you guys go ahead and do that? Can you guys give me A and B? You say when you plug in the 2 and the 4 for the fraction, you just plug it in regular. My question to you is what's regular?
Just writing the coefficient.
And what is that coefficient for both of those equations for that A coefficient?
Half and
It's 1/2 and 1/4. Very good. Yep. There's a 1 in front of this A. So this is the same thing as saying 1/2 A and 1/4 A. Still there. Still there. It's just written in that combined form. So I'm doing this one using the matrix C's for the people who need the matrix. So I'm going to quit out of this program. I'm going to go to matrix, go over to edit. This time I have a 2 by 2, not a 3 by 3. I have 2 unknowns, 2 equations. It is 1/2 and then 2, and then it is 1/4 and 4 for my first matrix. I go back to matrix and go to option B, and I.
A equals.
So it's going to be a 2 by 1, and then I'm going to type in what they equal. Okay. So remember, if you're using the matrix option, once you get all that information in, you basically need that formula that you still see on my screen. So you go back to second matrix, so second x to the -1. It's matrix A raised to the -1. Second matrix, option B, and then you have your solutions. Did you guys get this?
Yes.
So the 36 represents A, and the -1 represents B. So that means that my model, so my answer for part A, for the model that's connecting H and R is going to be H equals 36 over R minus R. Because technically B was a -1, correct? So there you go. Oh, excuse me. Alright, so for part B, we need to use the formula for the surface area of a cylinder to explain why a model of this form is reasonable. Well, suggestions. How can we explain that this is reasonable? Well, the only thing we've done is actually find the value of A and B. But it says to use the formula for the surface area of a cylinder. If it tells you to use a formula, you probably want to use that formula in your explanation. What is the formula for a cylinder?
Hold on.
Every single one of y'all got a reference booklet.
Nice.
That is part of it.
Wait, we're trying to find area, right? Or-
Surface area of a cylinder, yep. You can always go back and look in your geometry and trigonometry section. Wait, say that again. What is it?
I mean, you have two areas of the circle.
Two areas of the circle.
And then you just have the normal base and height of the rest of it.
You have the main thing is that you have two
Oh shoot, is it 2
circles.
pi
So
r?
it's 2 pi.
2 pi r h.
2 pi r.
Yes, it's
I
2
finally-
pi r squared plus 2 pi r h. The reason why, I guess you were looking at a specific example for that one. We were talking about it. We didn't use the top, but you got to think this is a cylinder here. Okay, so 2 pi r squared plus 2 pi r h. Now, when you look at this equation, okay, when you look at this equation, what do you notice about this equation for surface area? It has an r and an h. It basically has two variables. Actually, it has how many? It has 3. Have we ever dealt with an equation up to this point in your math career where you've had 3 variables and only 1 equation?
No.
Not sure.
You guys haven't done that, okay? You've done 1 equation with 2 variables. So, since I have 3 variables here, I have an r, I have an h, and I have an s. Well, the one thing is I can't change that s, because s represents my surface area. But the reason why this model is reasonable is because this model basically solves for h in terms of r, which means that I could plug this equation in for h and only have r be on the left side of that equation. It's substitution, exactly. Okay? So, in your own words, explain why this model is reasonable for the surface area of a cylinder. Go ahead and do that now. So, now that we know that I can use that model inside of my surface area of a cylinder equation, I can find that constant surface area for these particular cylinders. Because remember, in the description, it basically said that the relationship between the height and the radius of the cylinders that have a constant surface area. So whether or not the radius is 2 and the height is 16, or the radius is 4 and the height is 5, I should have the exact same surface area. Okay? So how do I find exactly what is that surface area? What do I need to do? Plug in h, and then? And how do I solve? Once I plug in h, so then this gives me 2 pi r squared plus 2 pi r 36 over r minus r. Once I plug that in, how do I actually find that constant surface area? But that's not actually telling me, like, I'm looking for an actual numerical value. Like, what is the surface area when the radius is 2 and the height is 16, or when the radius is 4 and the height is 5? I could use, and do what? Substitute it in. I can just plug it in. And it doesn't matter which one I use because they should both be it should be constant, so it should be the what? What's another word for constant? The same. So you can either pick 2 and plug it in to get the surface area, or you can pick 4 and plug it in. And this is what I want you guys to do. This side, I want you to plug in 2 and get the surface area. This section, I want you to plug in 4 and get the surface area. Okay? But since I've already used h and plugged it in, I only need to plug in the one number of the coordinate. Okay? So go ahead. You guys are plugging in 2. You guys are plugging in 4. It should be the same no matter which one you plug it in. And I'm just plugging this into my home screen. No application for this. I'm just looking for the surface area. When I plug in 2, what do you guys get for the surface area?
26.194671.
So 3 significant figures would be 326. 226. What squared? Centimeters squared. My people who plugged in 4, did you get 226? There you go. So it doesn't matter. Don't forget your units because we are talking about volume, or not volume, talk about surface area. Make sure you always include your units. So right now, this is connected, part A connected what we're learning now, the systems of equations. Part B and part C is using geometry and trigonometry here. Surface area of a cylinder, being able to evaluate a particular, for a particular variable. This is how those like longer response questions can incorporate multiple topics into one. Okay? Kind of similar to what your midterm is going to be like. Yeah? Okay. So when I look at part D, it says to use your model to find the value of H when R is 9. And of course, is your answer reasonable? How do I find the value of H? Plug in the R, which is 9, into what?
A.
The H.
Into A, the H thing. So this becomes 36 over 9 minus 9. What's 36 divided by 9? 4. So this is basically 4 minus 9. What's 4 minus 9?
Negative 5.
So this is negative 5 centimeters. Is that reasonable?
No.
No.
No. Why is that not reasonable? You can't have a negative 5 centimeters. Because that 5 centimeters is supposed to represent what?
Or like area.
It doesn't represent area. Remember, we plugged in that 9
Yeah.
to find the what?
Height.
And you can't have a negative height, can you?
I don't think so.
Because we're talking about a cylinder. It's probably like a can of beans or something like that. I don't know. But for what values of R can this model be correctly applied to? No, not any, because we just saw when R was 9, it didn't work. So the question is, what are my values of R for which it will work? Give you guys a second to brainstorm that before we actually answer it. So we know, because I wasn't recording any of this, so we know that the height cannot be 0 and it cannot be negative. So that means that H is going to have to be greater than 0. So because of that, what we can do is to find the values of R, we can set our height equal to 0 and solve for R. Now, those who use the graphing feature, you didn't have to use it. You could have added R to both sides, then multiply by R, square root. And the square root of 36 is 6. Okay? We know we can't have a radius of 0 because that also makes no sense. So your values of R that this model can be applied to is between 0 and 6 centimeters. And you would write it as a compound inequality because we are talking about a range. Okay? So your range can be so small, it can even be 0.1 centimeters, or it can even be 5.99 centimeters. Okay? So that is how you use, that's how we use technology to find or to solve a system of equation. And this last example is a great example because it incorporates other things along with it. Okay?